Good morning, Vipers. It's great to have you guys back here learning with me again today. I hope you guys had a restful week off, or if you needed to, use that time to catch up on your work so you're feeling rested and ready to go, staying up with our new assignments going forward. Today, we are about to start something we call composite or combined area of irregular figures. It's one of my favorite parts of math because it really involves a lot of parts of your brain. It's very visual. As a result, I'm going to do a lot of screen sharing. I'm going to try to experiment with some ways where you can see my work on a paper too. Really excited to work with you guys on this today. I'm going to keep the video a little short, give you a lot of answers to check your work because this standard is all about practice and doing the best you can. So again, I'll show you my work so you can see how I solve it. And I really can't check that you're showing it your work this way because you can't show on a computer, but do the steps I do because it's going to get harder from today. So today's our first day of this standard, and Wednesday we go to a little bit harder level, and then Friday we have like kind of level 3, the hardest level for these questions. So take your time with it, use the steps I show you, and you're going to be fine. Let's get that problem solving task opened up on your Google Classroom. Go in there. Last week there's a problem with someone wouldn't let you edit them without opening a new window. I apologize, that is entirely my fault. This week it should be good to go. Edit in the Google document on Google Classroom. You can submit it, but you're going to need some paper and a pencil to make this work today. Simply copy things down, or if you have a printer, you can print the papers up. Let's get going. All right, here's our problem-solving task. It says, while setting up a haunted house for Halloween, Jose wanted to put paper on a part of the wall. A picture of the wall he was putting paper on is shown below. How many square meters of paper does he need? You can see that Jose has measured all sides of the wall. It's measured in meters. M stands for meters. And we want to find how many square meters of paper he needs. So we're going to pause the video as always. You try this on your own first. Show you can learn it or try it yourself. And pause it and come back. We'll go over the answers together. We want to find out how much space on this wall he needs to cover up. To make this easier for myself, since I'm trying to work on a computer with complicated shapes, I've drawn a basic example of what it's shown on there. Again, it does not have to be exact, and you don't have to make sure the lines are all the same exact size. If you want to, some people like to trace it on the computer screen. If you do so, do it really lightly. You don't want to break or scratch the computer screen, but you can put the paper right up against the screen to get the shape. So how much space was taken up on the wall? So the first thing I've seen people do, and I've seen students do this every year, is adding up all the sides. 7 plus 5 plus 3 plus 2 plus 4 plus 3. The question you're going to ask is that going to give you the space on the wall? If you add up all those lines, do you have the space that's there? The answer is no. What you've done is found the perimeter of the shape, which is important if you're trying to put a line around the outside. But we're not talking about the outside. We're talking about area, space inside. And take a second. What is the formula for area? That's right. Down below, you can see area equals length times width for a rectangle. This is a rectangle? It's not. We cannot times length times width because what you can do is you can multiply 3 times 7 times 5 times 3 times 2 times 4. That number is going to be really big. And that's also a formula that only works for rectangles. So if you haven't done so already, take a second, look at this on your screen here, or go in your problem solving task and find me some rectangles. Pause the screen, go. All right, I'm hoping you came up with some rectangles in our shape because we only know how to find the area of a rectangle, and this is not one. And you'll see there are actually 2 correct ways to do this. Neither one is more correct than the other. You can break up the shape. That's the only way to do this. And then there's no other formula you can use. So you can break a line across here or go up here. Just to keep things simple, I feel like the one I saw first was a line going this way. I'm going to solve and work with you guys breaking it up side. If you went to the top, that's fine, but I'm going to do it the other way. So do that with me right now on your paper if you haven't done it already. Break that line across and make 2 rectangles. All right, we've got our 2 rectangles now, and what I'm going to do to make things easier from here on out, I'm going to label my rectangles so you know what I'm talking about, because it's now 2 shapes. What we call it composite, or a composite shape means made of more than one. Anything that's a composite is made of more than one thing. There's 2 rectangles here. So I'm going to label the top one A and the bottom one B. So from now on, when I talk about the area, I'm going to talk about the area of A and the area of B. So take a second right now. Again, if you haven't tried it on your own yet, stop now, find the area of rectangle A, find the area of rectangle B. Go. This as still as I can because this is where it gets tricky. So far, everything I've done, I think you can all do no problem. But when it comes to finding the area of rectangle A and B, there's a lot of ways to get tricked. And that's because I have a lot of numbers here. And a rectangle only needs a length and a width to get the area. The first way you could have been tricked, and that probably some of you did, is saying the area of A was length 7 times 5. Think about why 7 times 5 is not the way to solve for A. Hopefully you realize, looking at the whole shape, 5 was not this length, was not the width of A. That was the width of the whole composite shape. 5 is no longer a helpful number to us here. The width of this is 3. So the area for A, area equals length times width. Area equals 7 times 3. Area for A equals 21. I want to show you how I do that with my worksheet, what your work paper should look like to solve this and get it right. Let's do that. I'll write out the formula for area A, which means the area of A. Area A equals 7 times 3. You could say 7 meters times 3 meters too, if you want even more accurate. But then I get area, I should actually have written area A equals 21 square meters. But hopefully you're realizing I'm not done. I have to get the area of B. And luckily, B is a little harder to get tricked down here because this 5 measures this whole side here. We don't see that part broken off here, so it looks like it's just 2 times 3. That's true. The length of B is 3. The width of B is 2. So all I need to do is write my formula. Area B over here. A little sloppy here. My pen is running out of ink. Apologize. We can see I wrote area B equals length times width. Area B equals 2 times 3 because the length is the length and width are 2 and 3, and the area of B equals 6 square meters. These steps may seem like a lot and it might seem unnecessary, but remember this is Monday. We have a lot more days of this coming up, and this is the first most basic day, so I want to build this habit before the questions get hard. Once things get hard, you don't have the habits of organizing your work off to the side with area formulas, it's going to get really challenging for you. So I have A and B, and think, what do I need to do with this to get the area of the whole shape? And basically, students always tell me one of two things. You multiply the area of A and B, or you add the area of A. And think what multiplication or adding do. Multiplying means taking many groups of something. Are we taking many groups of A and B? No. Are we adding means combining or putting together. Are we putting the two together? Yeah. We're going to add A and B. So our area of A was 21 meters squared. The area of B was 6 meters squared. So all I do is put that together. 21 plus 6 equals 27 square meters or meters. That's our final answer. That's an area problem, area of a composite shape. So let's review the steps real quick. I'm going to put them up on the screen in writing here. The first step you need to do is to figure out if it's an area problem. Once you know it's an area problem, then you need to break up the shape into rectangles because we know how to find the area of rectangles. Then you need to write the formula out for the two pieces of your shape, length times width. Once you've written the formula out, you can then add numbers in instead of letters. Help you figure out what the area of the entire shape is going to be. The final thing, is to add the area of A and B, sometimes A, B, and C even when we get more challenging. Add together those areas. Read those down. Write them down. Make sure you're doing those steps as you solve problems today. Let's go to practice and crank out a few of these problems. All right, friends, here we are at our guided practice page. I want to remind you that it is nearly impossible to do these problems just on paper, on the computer, if you can't draw or you don't have paint to work with them as we go on. Today you might be able to. I'm going to be doing guided practice just to help you go over the answers you're getting. So you need to try these problems yourself. I'm going to summarize how they're solved, but again, you need to try them yourself first if you have any chance of learning how to do it. So our first one on here in guided practice, I'm going to kind of just try to show you what I'm doing with my cursor here and then write down the steps down here. What I'm going to do is, to make it simple for today, what I see, I just break it up the way I see it. There's two ways to break the shape up. You can break it into 3 pieces, but I'm going to break it into 2 right here. I'm going to draw a line from the 2 here down to 2 here, which makes rectangle A and rectangle B. Rectangle A, I'm going to say area A equals length times width. And then I can just write again, area A equals, so my A rectangle, the length is 9, the longer side is 9, the shorter side is 5. These 2's are not really going to be the full length or width of the shape. So 9 times 5. 9 times 5. Now I can say area A equals 45 square centimeters. You can use the abbreviation for centimeters. So that's A. I'm not done with the problem. I just found the area of my first rectangle, which again is the one on this side. On the other side here, I have my second rectangle. Oops. That's 4 and 5. These 2's don't actually help me understand the size of these rectangles. When we get to harder ones, they will. So my area, area B equals length times width. Always length times width. Area B equals 5 times 4, the longer side times the shorter side. And then just going to the next side, area B equals 20 square centimeters. So I have the area of the 2 shapes, but now I need to put them together. So I write total area, that's the area of the whole composite shape, what we're doing today, equals 45 plus 20 for a total of 65 square centimeters. Reminder, that's when me breaking it up this way. You might have different work if you broke up the rectangle differently, but if you're checking your work with me, the answer's the same no matter what you do, 65 square centimeters. Under a second one, I got to practice real quick. We have, it's a little blurry, but I'm going to do my best just to explain it to you here. We have a crazy L-shaped rectangle here. I'm going to try to write my work over here. I'm going to move this a bit so I have some more space to write my work down. So I'm not doing it on paper. If I could, I'd be showing this to you on paper, but it'd be slower that way. So I'm going to break this up in the easiest way I can see, and that's kind of to chop the lower leg off of this here. So this is going to be A on top, my shape A up here, and shape B down here. Right, area A equals, now you got to think, is the area for A going to be 9 times 15, well, length times width? Is the length 15 or 9? And remember, I draw my line all the way across here. I'm cutting off this leg right there. That means this whole thing is not 15. It's got to be 19, from all the way from this end all the way to that end. That's where it's going to be. So it's going to be area A equals 9 times 19. Okay, in my head, 9 times 10 is 81, or so 9 times 9 is 81, 9 times 10 is 90, so 90 plus 81 is 171. And that's going to be square millimeters. Area B is going to be down here. I'm chopping this off. So I need my length times width. What's the longer side is going to be, well, it's going to be 17 or 26. Which one is actually the longer side of B? Remember, it's getting cut off here. So which is longer? It's not going to be 17. It's not going to be 26 because that's getting split. That side is no longer 26 long. 17 is the length. So area B equals 17, and then the width, the shorter side of this rectangle, is 4. 17 times 4. In my head, 10 times 4 is 40, plus 4 times 7 is 28. So 40 plus 28 is 68 square millimeters. I have my rectangle A, rectangle B. Got to get the total area. Is going to be an addition problem. Total area equals 171 plus 68. I gotta be honest with you, I'm not good at adding in my head, but it's gonna be 9. 6 plus 8 is 7 plus 6 is 13. 3, 2, 239 square millimeters. All right, hopefully that makes sense to you. It's getting you on the right track to solve those problems. Remember the steps, they're back in the earlier in the video. Write them down, follow those steps, write them all out just like I did here, but do it on paper so you can actually draw on these shapes, maybe cross off the lengths you don't need. I'm gonna find a way to do that better for you, maybe do it on a tablet or find another way to make this happen. But for now, do the best you can do. I'll see you guys on Wednesday, and if you're in DePaul, I'll see you at office hours tomorrow, 12:30. Great to have you guys back learning. Have a great day.